Here we will learn about additional rule and conditional probability. All our real world problems we need to read and understand. It's very important you look into these figures, the numbers, these are very important things. So let us look into it. Scholarships. A review committee read 3,000 application essays for one $5,000 college scholarship. So the total is 5,000. Since it's the writing part of the exam, you can write total applications given this is equal to 3,000. The step 1 is given, whatever is given. Of the applications reviewed, 2,865 essays were of required length. Now, don't write P or anything. You can just write applications of required length. Required length. That's given to be 2,865. And what about the next one? 2,577 of the applications at minimum required grade point. Applications with minimum, MIN is the short for minimum, grade points. Grade point. Applications with minimum grade points is over here, 2,577. And 2,486 at the required length and minimum grade points. Applications with both. But you need to write, what does both mean? Required length, I'm just going to write in short form, required length and minimum grade points. Okay, in the exam, write applications with both required length and minimum grade points. They weigh 2,486. So this is all given. Now then, what is the probability that an application essay selected at random will have the required length or required grade point? Here you can see this is the additional rule because or is mentioned. The rule is given by step 2 is find the required length or required grade point. That would be probability of A plus probability of B minus probability of A and B. Okay, so here you can write this as probability of A, not probability of A, sorry, it is just A, B, A and B. This is A and B. How do you write the probability? It is 2,865 divided by the total. How much is the total? It's 3,000 plus 2,577 divided by 3,000 minus the common. This is it. This will be the answer. You can just put in the calculator and you will get the answer. Here, few important things. Write what is given. Then this is the formula. It's a standard formula. But here, remember, whichever is told both, say over here, minimum grade points and it was the minimum required grade points and the length. Whereas, okay, over here, the next one. Required length and minimum grade points is this much, right? So this is and or intersection, P intersection B. Inverted U is called intersection. So that is very important. Figure out where it is. And what is the required length and the required grade points are given separately. You need to add them both and subtract what is the common. That is how you get it. And remember, always probability is given by desired by total. The total over here is 3,000, isn't it? So that's how we do it. We'll just put in the calculate. So we'll just put this in the calculator now. Here we have to put 2,865 divided by 3,000 plus, just go next and then plus. So let's type out what is known. It is 2,865 by 3,000. Next, it's adding with 2,577 by 3,000 minus the common terms, 2,486 by 3,000. So that's the answer. It is 739 by 750. You can write in fraction. Look into the Since it's the writing exam, you can write it like this or you can write in percentage. It's up to you. See, if you're writing this as the answer, you must get full marks. So no problem. This is the correct answer itself in fractions. But it's a simple thing to. But I would suggest you write it even in percentage. You can either put brackets and multiply it by 100, brackets and multiply by 100, or whatever you get the answer, write this separately multiplied by 100. It's 98.5%. Now they have not told round it off to the nearest tenth or anything. So 98.5%. I'm just going to write these two. Or you can write it as 0.985 as well. So that'll be the answer. So this answer is for this. The probability that an application selected at random will be required length or required grade point. So if you're wondering what was over here, it is, I forgot to write it, or B. So it can be either A or B. Any of these conditions, this is the formula given. So over here, you don't need to write it as length, grade points. You can even write instead of A, L for length, G for grade points. And instead of A, you can write over here L and G. That's up to you. But I just take the first thing as A and second thing as B. So you need to write so much, then you'll get full marks in writing as well. See over here, main concept is only that much. But it would be really nice if you write the given and then do this. Write a step of given all these values and then write whatever is given over here and then the final answer. I would suggest you to solve these problems by yourselves. You can pause the video, try them all by yourselves, and then you can look into the explanation. It's about pets. Ruby scattered 8 kittens. The litter, all the kittens, the group of kittens, means litter, included 2 orange females, 3 mixed color females, 1 orange male, and 2 mixed color males. Ruby wanted to keep 1 kitten. What is the probability that she randomly chooses a kitten that is female or orange? Probability of A, well, A is equal to female kittens. Female kitten, that is equal to how many are there female kittens? So 2 orange females and 3 mixed color females. It's total 5. It's not about the color, it's only about females. These are all males. Over here there are 5 females. And what about orange kittens? Orange kittens. Here we have orange. Over here there is 2 orange females and 1 orange male, that is 3. So these are the values. Now A and B, we need A or B. See, probability of A or B is given as probability of A plus probability of B minus probability of A intersection B, or A and B. So now we need to know what is A and B, isn't it? So what do we want is female and orange, which are female and orange kittens. Orange. Okay, this is the female and orange. Can you see 2 orange females? So it is 2. Now, what about these probabilities? You can write over here, probability of A would be 5 out of, what are the total kittens? 8. Probability of B is equal to, probability of B is equal to 3 over 8, and lastly probability of A and B, I'm just going to write inverted U for intersection, is 2 over 8. So all we do is we write them out, 5 by 8 plus 3 by 8 minus 2 by 8. Just put in the calculator, you'll get the answer. It'll be 6 by 8. So that's the answer. You can find the percentage as well. Just multiply this by 100. So 6 by 8 is 3/4. 3/4 is 75%. That's how we solve these. The remaining problem, okay, now this is about table. You can try this by yourselves. I'm just going to write directly. I'm not going to write detailed, okay? I'm just going to write probability of A, B, and the answer. The table shows the age and number of participants in each sports at a sporting complex. So what is the probability that a player is 14 years old age is 14 and plays basketball. So all you need to do is probability of A is 14 years old, right? Add all of them. What is the probability of A? 14 years, 28, 36, 42. It will be 28. So it's not 38, it's 28 plus 36 plus 42. What about the probability of B? It's basketball. Basketball, here it is 42 plus 33 plus 29. You need to write in detail. I'm just going to write this. Players who are 14 years old needs to be written over here. Probability of A, players who play basketball. Let's find the answer here. It is 40, 70, 80, 90, 100, 106. And over here we have 50, 90, 100 and 104. Now there is one more probability. Probability of A and B. What does that mean? 14 years old and basketball. So who are playing basketball who are 14 years old? This is the number, right? 14 years basketball. It's 42 people. So the probability of, now again I've done a mistake. It's not probability of A, but if I've written probability of A, it should be just A. Let me just make that proper. It's just A, not probability. I'll write the probabilities below. Probability of A plus probability of B minus probability of A and B. Now, how do we write is 106? Yes, but we need to find the total as well. What is the total? You need to add all the boxes here. It's this plus all the numbers needs to be added. We'll just use the calculator because there are plenty of values. That is written divided by. Here it is 104 divided by the total minus 42 divided by the total. Now, whatever you get in the answer, the answer that is probability of A or B, that is 14 years old or basketball. It will be 28. Don't repeat any box twice. 28, 36, 42, 30, 26, 33, 35, 41, and lastly we have 29. And the answer is 300. So here every way we have to divide by 300. And again put that in the calculator and you'll get the answer. Here let's use fractions. 106 divided by 300 minus plus 104 divided by 300. That's over here 300. And lastly minus 42 divided by 300. The answer is 14 by 25 or 56%. So here we go. Let's look at this problem. Use a model. Vicente and Kelly are designing a board game. They decide that the game will use a pair of dice and the players will have to find the sum of the numbers rolled. Okay, Vincent and Kelly created the table showing to help. Basically, over here there are two dice. A die will have six numbers, right? 1 to 6. So either when you throw in two dice, you can get either 1, 1, 1, 2, 1, 3, and all these possibilities. There are total 36 possibilities. Each player will roll the pair of die twice during the player's turn. What is the probability of rolling a pair or two numbers that have sum of 7? What does it mean to rolling a pair? Same numbers. Now from this table, which have same numbers? 1, 2, 3, 4, 5, 6. This is rolling a pair. Or the sum must be 7. When you add it, it must be 7. Here, 6 plus 1 is 7. All these are less than that. But what about this is 7? Others are 8. It should be exactly 7. Sum must be 7. Here, 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 and here. So these are the situations. Are there any common? Look here, 1, 2. Are there any of these common or overlapping numbers? No, these are some of 7s which I'm putting in a rectangularish box. And the circles, there is nothing that overlaps. So there is nothing that overlaps. So the formula will be probability of A plus probability of B. That's it. Probability of A or B will be, there's no overlapping. So minus will be 0. No need of writing that. So what is the first probability? It is 3 plus 3. It's 6. By total is 36. Plus again 6 by 36. That's the answer. It'll be 12 by 36. 12 goes one time and three times. It is one thirds or 33%, 33.33%. So that's the answer. Here we go. It's 6 by, its pair is 6 of them, which I just marked, and sum of 7 is also 6. Now, the second part of this question is, what is the probability of rolling two numbers whose sum is even number and not rolling a 2? Okay, here, sum of even numbers. Whenever two even numbers are there, it'll be even, or two odd numbers. Okay, but whenever even and odd, it doesn't work out. See, these won't work out. This is even odd, and over here these are even numbers. Similarly, you can see here it is this and this. So how many numbers will be there? It will be, each row there are 3, so it's going to be 18. So this one here, here, all these are even numbers. So whatever I've just put a circle are even. So probability of A would be all even numbers. I'll write this formula: probability of A plus probability of B minus probability of A and B. So that is 18 out of 36 plus, what is the next one? Not rolling 2. Let me just change the color here. Not rolling 2 means I shouldn't have this. So let me just cut that off. Not rolling 2. This is not included. And this one as well. These, why I'm cutting this off? Because if there is 2 over there, that should not be there. All the others now here, all the other values, say I have this one, all those are included. So I'll just draw lines like this because they're all included here. Other than these pink cross marks, all of them are included. So which are those? 1 1, 1 3, 1 4, whichever doesn't have 2, isn't it? Let's count them. There's one easy way to count. How many 2's are there? 6, 7, 8, 9, 10, 11. So out of 36, 11 have 2. So remaining 36 minus 11 will be 25 out of 36 do not have 2. Not rolling a 2 is 25 by 36. So that's how we get that. And then what are the intersecting? See, can you see these both are intersecting, right? Basically, here this one, other than this, these 3 all will be, sorry, there are 5 which are not. Let's count it anyways. This one is intersecting. 1, 2, 3. They are all common. 4. What about this one? See, all of them. 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. You can see over here, other than the one which are excluded, here outside literally all are selected for the B, and whichever is there for A will be intersecting over here. So it's 3, 6, 7, 8, 9, 10, 11, 12, and 13. So it's minus 13 by 25. You just have to put this in the calculator and you'll get the answer. It'll be 12 over here. At 12, it's going to be 30 by 36. So this must be the answer. It is 6, 5 times 5 by 6 must be the final answer. Or it'll be 83%, 83.33%. So that's how we do this. I hope that's clear. If the table is given, it's very, very simple to understand. Now another problem, a similar one which we did a while ago. The table shows parks and recreation department classes and a number of participants' ages 7 to 9. What is the probability that a participant chosen at random is in drama? This is the one, and 8 years old. So this one over here and this one. So we just find the sum. 30, 51, 55, 65 is 8 years old. What are the total? You just have to find the sum of all these. We'll just use calculate for that. And over here we have 30, 50, 90, 100 plus 100 in drama minus, what are the common ones? These are the common who are 8 years old and go to drama. So you just have to divide by all the sum of these numbers. And then you just put in the calculator. Here we have 40 plus 35 plus 25 plus 30 plus 21 plus 14 added to 20, 44, and the last one is 11. So it's 240 of them. 240, 240, 240. And then you just put this in the calculator entirely, you'll get a single value. Let's just jump to the answer. You can see, yes, this is correct. They have written 100 by 240 first. That's absolutely fine because they are told drama first. I did second one because you're adding them up. You can write any order, it's okay. The final answer will be 3/5 or 60% or 0.6. Now the similar one again, Erin is planning a summer garden. The table shows the number of bulbs she has according to the type of color of flower. Okay, these are the bulbs, orange, yellow, white, and these are the flowers. What is the probability she wants? She selects a bulb for a yellow flower or dahlia. Okay, yellow and the dahlia. Simple numbers here. Dahlia, how many yellow are they? 5, 10, 11 out of the total over here. You just have to add them all. Plus, what is dahlia? 9, 12. Minus, what is the common term? It is 4 divided by. So if you find the sum of all these, just put it in the calculator. Here we go. It's 11 by 36. The sum of them is 36 plus 12 by 36 minus 4 by 36. And that's it. We move on to the conditional probability problem. Let's look into this problem. A Spanish club is having a potluck lunch where each student brings in cultural dish. The 10 students randomly draw numbered cards numbered with consecutive integers from 1 to 10. Students who bring odd numbers will bring the main dish. So there are 10 chits of numbers, and these 10 students who are there in the class pick them randomly. So if at all you get numbers, odd numbers like 1, 3, 5, 7, 9, you bring main dish. Whereas the students who draw even numbers, that is 2, 4, 6, 8, 10, will bring desserts. If Cynthia is bringing dessert, what is the probability that she drew the number 10? Dessert is something like a sweet, or after any meal you have any nice sweet, that is a dessert. Here we need to first know conditional probability problem is B by A. B condition A is given as A intersection B by probability of A. A is the condition. Now Cynthia is bringing a sweet or a dessert, so that means it is going to be even numbers. So probability of A is important. You need to figure out from the question, the last part, when they tell this is the probability to find what has already happened. This is the condition. This means bringing dessert means it'll be drawing even numbers. Probability of A is drawing even numbers. So even number. What is the probability of drawing even number in 1 to 10? It is 50%, right? Because there are 5 even numbers out of 10. So we'll just leave it like that. There are 5 even numbers out of 10. You can write 1 by 2, but I'll just leave it over there. The next one, no need of finding the probability of B. We just need A and B, or A intersection B. It's the same thing, A and B and this inverted U. So what is the probability that it can be either an even number or 10? How many 10s are there? Only one, right? 1 out of 10. So it's only one possibility because you need the specific number 10 out of the even numbers. So this is the only possibility, A and B. So A is even number, B is 10. There are only one possibility, and the total numbers divide. Probability means divided by the total. I'll write over here total number of students, right, is equal to 10. So whatever these probabilities you're finding will be divided by 10 only. So these are the steps required. Now you can directly do the step 2 formula. Let's solve it. Probability of B condition A is equal to probability of A and B is 1/10 divided by 5/10. So this cancels, it's 1/5. It's 20% chance. So she drew the number 10, provided she's bringing a dessert. So that's it. That'll be the answer. You can see over here. Okay, over here the sample space, this, that, and all is given. You don't even need to do that. See, it's just very, very simple. This is it you need to do. And there are other ways as well finding this out. There is other shortcut methods, but that'll be only good for direct calculator methods. But now, since you have to do in writing, you have to do it. The other methods would be, if Cynthia is bringing a dessert, what is the probability she drew? 10. So already we know this condition is what? Bringing a dessert is even numbers. What are the total possibility of even numbers? 5. 10, it's only 1 out of 5. So this is also possible, but this is the actual method. Better to do this. Let's do these problems quickly. A card is randomly drawn from a standard deck of 52 cards. A standard deck will always have 52 cards. So what is the probability that the card is a king of diamond, given that the card drawn is a king? This is the condition, given that. So probability, you need to write in detail. I'm just going to write the answer here. A intersection B by probability of A. Probability of A, what is it? The card is drawn as a king. How many kings are there in a set of deck of cards? 4. There is spades king. The spades like this. There is clubs. These are the 2 black suits. Then there are diamonds. Okay, that's a very bad diamond. It's a red suit. And there is hearts. That's red suit. So there are 4 suits, which are very, very badly drawn here. There are 4 kings, and there are total 52. Okay, now I didn't write it properly. That is probability of A. Let me write it over here. 4 by 52. What about probability of A and B? How many king of diamonds are there in the entire deck? It's only 1. So this cancels off. It's 1/4. Now, another way to check your answer. Probability of drawing a king of diamond. Condition, it's a king. How many kings are there? There are 4 kings, and king of diamond, there is only 1. So 1/4. So the answer is that. But you need to write the probability of A, just writing, and then put the formula and solve. It's about a game. In a game, a spinner with 7 colors of the rainbow is spun. Okay, rainbow has 7 colors, and find the probability that the color spun is blue, given that the color has 3 primary colors: red, yellow, blue. Over here, it's the condition, given that they have told 3 primary colors, 3 out of 7, and up above, what we have to write? The probability of A and B. It should be blue and common with this condition, and this, right? Blue is the only color which is common, 1 out of 7. Or you can also think like this, which is common here, only 1 common, and how many total are they over here? It's 3 1/3. Or the 7 cancels. Answer is 1/3. Over here we have about cards. 15 cards numbered 1 to 15 are placed on a hat. What is the probability that the card has a multiple of 3 on it, given that the card picked is an odd number? Now down 1, we just need odd numbers out of 15. Sometimes students tell it's 7 and some tell 8. 15 by 2 is 7.5, approximated to 8, because we start with 1, not with 0. But the actual method, see, the cards are very less. So just write out the odd numbers: 1, 3, 5, 7, 9, 11, 13, and 15. Why it is important? Because we need also the second one. Now, I'll just write this out. It's 3, 6, 8 out of 15. But what are the multiples of 3? First, write the multiples of 3. It's 3, 6, 9, 12, 15. Don't write here 5. What are the common? Because we need this and this. These both and, isn't it? The formula is probability of B condition A is P and B. Then inverted U is intersection, or it means and. Both of them must be there. Then probability of A, the condition. So here we have 3, 1, 9, 15. So there are 3 out of 15 that are common. So it's 3 by 8. That's the final answer. So here we go. Here we have been told about marbles. A blue marble is selected at random from a bag of 3 red and 9 blue marbles and not replaced. Okay, this is important. What is the probability that the second marble drawn will also selected will be blue? So probability of B condition A is given as A intersection B by A. It's very easy to find the condition. What is the probability that the second marble will be blue? But that's not the condition. What is the condition? This one. A blue marble is selected at random. So probability of A down, what is the possibility of selecting a blue marble? There are total 9 out of 12. Very simple, right? Or you can write it as 3/4. But what is probability of A and B? A and B means probability of having a blue marble, 9 by 12, and again next one will be blue marble, right? What is the condition of second one being blue? Here, out of 9, 1 is gone, it will be 8, and out of 12, 1 is gone, it will be 11. Why? Because it's not replaced. You took one marble from here, out of 9, 1 is gone. 8 are remaining. Even out of the total, there are 3 red, yes. But now, instead of 9, there are only 8 blue marbles. So this is the condition. Now you need to simplify this. 2 times, 3 times, 3 1 times, and over here 3 times. It's 6 by 11. So here you just write 6 by 11. Now you need to put that in the calculator and then solve it up. You will get the final answer. Just this. It's 6 by 11. And why they have written 3/4 is 9 by 12 is 3/4. Just put in the calculator. It's 8 by 11. And that's 73%. That's how we solve it. It is conditional probability, but just that A and B, remember, first one, 3/4 is 9 by 12. Say 9 by 12 or 3/4. That's why I written 3/4. Next one will be 8 because one blue is gone, and out of 12 there will be 11 only. A die is rolled if the number rolled is less than 5. Okay, that's the condition, less than 5. How many numbers? 4 out of 6. In a die there are 6, right? What is the probability that the number is 2? Probability of A and B will be 2 or less than 4. How many are there? Only 1, right? Because they have told less than 4 and 2. So 1, 2, 3, 4 and 2. Only 1 is the common term. So it's 1 by 4th or 25% here. So 1 by 6 divided by 4 by 6, 25%. If 2 dice are rolled, what is the probability that the sum of the faces is 4? Given that the first die rolled is odd. Okay, now 2 dice are rolled. You remember the box, right? Where we had 1, 1, 1, 2, 1, 3. The same thing needs to be remembered now. We don't need to draw it up. If 2 dice are rolled, what is the probability that the sum of the faces is 4? So what will give you 4? It's either 1 and 3. So 1, 3. I'll just write it in terms of 1, 3. 3, 1. This is also going to give. And given that the first, okay, now here there is a very important thing. First die rolled is odd. If you are rolling the first die odd, what is the total possibilities? Out of 36, it's only half of it. 18 out of 36. That's the first condition. Half of them can be only the first die must be odd. That's the given condition. It's half, 50%. It'll be either odd or even. The next condition is very important now. We need to find the sum of 3. The sum of the faces of 4. So there are 2 dice. But here we are not going to write all the possibilities. We are not going to write 2 and 2. Why? Because we need to have the first die odd. So 1 and 3 is true because it's odd. Even 3 and 1 is true, it's odd. What about the other things? 2 and 2 not possible because it's even numbers. 3 and 1 already is written. What about 4? 4 and 0 is not. Okay, only these 2 are the possibilities. No, nothing else, right? Yeah. So you don't need to draw it because there are no other numbers. Think of this. If you just change this number even more than 1 or less than 1, it's not possible anyways. There's no 0. You won't get 4. So only there are 2 possibilities. So the answer is 2 by 18 or 1 by 9. So that should be the final answer. It's 1, 9. So you can see here they have written all the possibilities, but you don't need to do that. See, these are all the possibilities. From this, okay, this is the odd numbers. From this, you have to find the sum of a sum that gives you 4. 1 and 3 and 3 and 1. If you count all the others, it will exceed that, more than 4. So the answer will be 1 by 18 divided by This is actually 18 by 36, which I have written over here. 2 by 36 and 18 by 36. Answer will be same. A spinner numbered 1 through 12 is spun. So there are total 12. Find the probability that the number of spinner is an 11, given that the number spun was an odd number. So out of this, possibility of odd, 6 by 12 or 1 by 2. And out of odd, how to get 11? There is only one possibility of getting 11, so 1 by 2. So that will be the answer. 1 by 12 divided by 6 by 12, it's 1/6. If two dice are rolled, what is the probability that the sum of the faces is 8, given that the first die rolled is even? Even die again, even or odd, it will just be 50% or it's 18 by 36. What about the above one? Let's write. It should be even. So I can't use 1. 2 and 6 is the only possible sum to get 8. Then 3 is not possible. 4 and 4 is possible. And then what else? 5 it's not possible. 6 and 2. So there are only 3 possibilities out of 36 that will give us 8 and even number. This is it. It's now 3 by 36 is how much? 1 by 12, because the table of 1 and 12 goes 1 by 12, and this is 1 by 2 is the same answer. Or you can just solve it up over here. It will be 3 by 18. That's 1 by 6. Yes, that's the correct answer. A school picnic offers students hamburgers, hot dogs, chips, and a drink. At the picnic, 60% of the students order a hamburger and 48% of the students order a hamburger and chips. What is the conditional probability that a student who orders a hamburger also orders a chip? So here let me take student hamburgers as A, hot dogs as B. Students orders hamburgers, hot dogs, chips, and a drink. Now let's look at these to understand which is the condition A. 60% orders a hamburger, that's A. 48% orders hamburger and chips, that is A intersection B. So let me remove these from here. So let me write probability of B condition A will be equal to probability of A and B divided by probability of A. What is the conditional probability that the student who orders hamburger also orders chips? So here we have the percentages, right? A intersection B is how much? 48% divided by 60%. Percent cancels anyways. So that will be the answer. Just put in the calculator, you get the conditional probability. Let's do it in the calculator. Here it is 48% or 0.48 divided by 60%. Also, if you don't write the percent, it's fine. The answer must be 4 by 5 or 80%. Yes, that's it. So the next part of the question, A, if 50% of the students ordered chips, are the events of ordering hamburger and ordering chips independent? No, they're dependent on each other, right? Over here, the values we got 80%. No, it's not the same. Here, it's no, they are dependent on each other. And if 80% of the students who ordered a hot dog also ordered a drink, and 35% of all students ordered a hot dog, what is the probability that the student in the picnic orders a hot dog and drink? Look over here. The conditional probability is given. Here, the condition is 35% of all students ordered a hot dog. That is A. Hot dog is A. A, the condition of B and A is over here, and we need to find A intersection B and drink. Okay. Let us write probability of B condition A is equal to probability of A intersection B divided by probability of A. Now here, this is given as 80%. And what is the probability of ordering? The condition is only 35%. The above one, probability of A and B is required. Just put in the calculator, you'll get the answer. Take this 35 to the other side, multiply it with 80%. Here, all we have to do is 80% or 0.8, you can take it as multiplied by 35%. Shift and here. The answer is 0.28 or 28%. That's the final answer, as you can see. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.